Hello wonderful person, this is Anton, and today we're talking about recent updates in regards to TRAPPIST-1 system. We're going to talk about what scientists have discovered and what they think is happening in the system, and most importantly why we think it's probably not going to be any good for us to go there. Anyway, welcome to What the Math. So this is not exactly the TRAPPIST system you might think of. This is a system I destroyed completely by accident by colliding with a few things. But it might not be far off in terms of habitability of the actual system. Anyway, so we're going to go into the TRAPPIST simulation right here. And this is kind of our current understanding of what's happening inside the system. There's a red dwarf in the middle, there's 7 Earth-like planets, and there is what's known as a habitable zone where we think liquid water might exist. Now, all of this sounds really amazing on paper, and we even think that maybe, just maybe, either this or maybe this planet is actually going to be kind of habitable. At least so we thought. And then came a few other scientists and a few other studies, and we've discovered that, well, first of all, red dwarfs are really dangerous. Especially the ones like TRAPPIST, which are sometimes known as flare stars. They actually flare up quite a lot. Let's just wait for one of these flares to occur so you can see. Now don't forget, here's actually one. Don't forget, the flares, even on our planet Earth, even though Sun is so far away from us, can actually be pretty dangerous. But TRAPPIST planets are very close to the parent star, meaning that a single flare is going to produce 1,000 to maybe 100,000 more stellar pressure and a lot more radiation. So imagine a planet similar to Earth receiving like 100,000 more radiation than it would be otherwise. And well, that's one of the problems. And here, every time a flare occurs, the temperature of the star jumps to about 8,000 degrees. Let's see how high this actually gets if we do that. So we're going to just manually do the 8,000 degree temperature and just watch what might actually happen. So obviously the planet will suddenly start warming up and heating up, and obviously this doesn't last for too long, but because it happens relatively frequently, this means that the planets get irradiated quite dramatically. And this also means that the actual radiative power of this star in comparison to our sun can go up by like 1,000-fold. So if we look at luminosity here, currently it's only about 0.004% of our solar luminosity. But if you were to increase this by 1,000, so for example when a flare occurs, or just in general because this star actually emits a lot more UV radiation and a lot more actual X-rays, if you do that, watch what happens to all of the planets. Now, even if it's just temporarily, all of the planets suddenly start heating up dramatically. Now, we don't expect this type of effect, of course. This is an extreme situation, but this might happen once in a while when the star flares up. And the more it occurs, the more likely these planets will start experiencing tremendous amounts of heat. Now, even if these planets have some kind of a protection effect, for example, magnetic field, which we'll maybe add to some of them just to simulate this. So let's go here and add the magnetosphere. That's going to be very powerful, just so that we can actually protect these planets from the solar radiation of TRAPPIST-1. Even if there is magnetic field, because they're so close to TRAPPIST and because they're actually tidally locked to TRAPPIST, there's actually a very high chance that is magnetically locked with these planets. In other words, the magnetic field of TRAPPIST-1 is essentially enveloping all of the other planets, and its radiation can easily fly through this magnetosphere and bombard the planets directly, which is a horrible thing to have as if you're a planet, because that means that you won't be able to protect your atmosphere at all. So in other words, what this means is that The actual magnetosphere from TRAPPIST-1 is basically enveloping the entire solar system here, so these things, even if they have magnetosphere, will not really be helped by them at all. So that essentially creates another problem with not only potential life on these planets, but also the idea of atmosphere, which would be completely stripped if this was true. And so basically, the combination of these super powerful flares that happen very, very often, as a matter of fact, pretty much every single day, and the fact that the magnetospheres are all linked together means that not a single one of these planets probably has any atmosphere on them. They're all probably barren, just like what you see right here. Now, they still might have some water on the surface in terms of, ice form, and they might even have some ice water hidden underneath the surface, but even that is being stripped actively by the super powerful radiation from these relatively small but very powerful red dwarfs. And so what this all suggests is that being in a habitable zone is just not enough, especially when it comes to red dwarfs. For a planet to actually have good conditions to basically have, liquid water, atmosphere, and maybe magnetosphere, they have to be very, very far away from these red dwarfs outside of the habitable zone. So they have to be pretty far. And that also means that you would probably not have any liquid water there. You would probably not have any kind of possibility for habitable planets. So in that sense, red dwarfs might actually be the worst possible stars to look for a future home for us. Now, that doesn't mean that all of the red dwarfs are going to be like this, because there are actually red dwarfs that might be old enough where the flaring has actually stopped. Now, one such system is actually very close to us. I've previously talked about it. It's the star known as Barnard star, and it's only about 6 light years away from us. It's a red dwarf that has actually mellowed down throughout the years. It's very, very old, and it has kind of stopped flaring up as much. So for all we know, it might actually have random rocky planets around it in its habitable zone that have with time acquired atmosphere, and that would also suggest that there might even be some sort of liquid water. So there might be liquid worlds around Barnard star, and for all we know, this might be actually our future home if we actually discover any of these terrestrial planets there. But for now though, TRAPPIST-1 is definitely not going to be a place where we might find anything comfortable to live in, and most red dwarfs will probably fall in the same category. So that's very unfortunate for us, because not only is it TRAPPIST-1, but also the closest neighbor known as Proxima b. Proxima Centauri and Proxima b have the same problem, with this being a very powerful flare star, and this planet Proxima b being a little bit too close to its parent star. Well, anyway, that's all I wanted to talk about in this video, and hopefully you learned something from it, and hopefully now you know that chances are these planets are going to be very dangerous to live on, and actually even going into these systems and trying to land on these planets, flying through this solar system, is going to be tremendously dangerous because of the solar flares. The radiation experienced by astronauts here would be like 100,000 times more than staying in the International Space Station, and chances of dying horribly is pretty high. Anyway, I'll see you guys tomorrow. Sorry for the sad note. Hopefully we'll end on a better note in the next video. Come back tomorrow to learn something else. Subscribe if you still haven't, and share this video with someone who enjoys learning through video games. See you tomorrow. Space out. And as always, bye-bye. And since I started with destroying TRAPPIST-1, might as well finish by destroying TRAPPIST-1 yet again. And look at all of these planets kind of burning. I think they're going to start burning anytime soon.